Okay, let us start with taking basic variables and their mt raised to minus 3 theta raised to minus 1 a1 into ml raised to minus 3 b1 into l raised to c1 lt minus 1 raised to d1, and this is ml minus 1 t1, right? For m 0 is equals to a1 plus b1 plus a1. 0 is equals to, for l 0 is equals to minus 3b1 plus c1 plus d1 minus 1. For 0 is equals to, for this is for t, this is for theta, 0 is equals to minus 3a minus d1 minus 1, and this 0 is equals to minus a1, right? Solving the above equation, solving this equation, then a1 is equals to 0, b1 is equals to minus 1, c1 is equals to minus 1, and d1 is equals to minus 1. So pi 1 term is equals to rho minus 1 d minus 1 v minus 1 mu, that is pi 1 is equals to mu divided by rho dv. This is pi 1 term. Similarly, we have to find out the pi 2 term. Then similar, we have to use Buckingham pi theorem. L0 t0 is equals to, put down dimensions, mt minus 3 theta minus 1 a2 ml minus 3 raised to b2 l raised to c2 lt minus 1 d2, and this is l square t minus 2 theta minus 1. Similarly, for m, this is for m, this is for l, this is for t, and this is for theta. We can write as 0 is equals to a2 plus b2, then 0 is equals to minus 3b2 plus c2 plus d2 plus 2, and this is 0 is equals to minus 3a2 2 minus d2 minus 2, and this 0 is equals to minus a2 minus 1. Solving above equation, we got a2 is equals to minus 1, b2 is equals to 1, c2 is equals to 0, d2 is equals to 1. Then pi 2 is equals to h raised to minus 1 rho vcp. So pi 2 is equals to cp rho v divided by h, right? Since dimension of h and k by d are the same, hence we can write as also pi 2 is equals to cp rho vd divided by k, right? Next we have to find out the pi 3 term. In the pi 3 term, see here, for the pi 3 term we have the pi 3 term, right? That is, I'll write here pi 3 is equals to m l 0 t0 is equals to mt minus 3 theta minus 1 a3. This is ml minus 3 b3. This is l raised to minus c3, and this is lt minus 1 d3, and this is mlt minus 3 theta raised to minus 1 is equal, right? This is for m term, this is lt and theta. We can write as 0 is equals to a3 minus 3b3 plus 1, 0 is equals to minus 3b plus c3 plus d3 plus 1, and 0 is equals to minus 3 a3 minus d3 minus 3, and 0 is equals to minus a3 minus 1. This is about the theta, right? These are the calculated values. So a3 is, by solving minus 1, b3 is equals to 0, c3 is equals to minus 1, d3 is equals to 0. So pi 3 is equals to h minus 1 d raised to minus 1 k. So pi 3 is equals to k K by HD. Pi 3 is equals to K by HD. According to pi theorem, pi 3 phi is equals to, we can write as for the force convection, so we can write as pi 3 is equals to phi into bracket pi 1 by 2, and this is K by HD is equals to C into bracket mu rho dV raised to m dash, and this is Cp rho dV divided by K raised to n dash, right, where m dash and n dash are constant, and if m dash is greater than n dash, then we can write as K by HD is equals to C into bracket mu divided by rho dV bracket close n dash into another bracket Cp rho dV divided by K raised to n dash, and this is mu rho dV into bracket this is mu n dash minus n dash, m dash minus n dash, right. So equation becomes C into bracket mu rho dV bracket close m dash minus n dash into another bracket, we have to combine these two, so mu divided by rho dV Cp rho dV divided by K raised to n dash. By solving our this rho dV will get cancelled, then C into bracket mu rho dV raised to m dash minus n dash, so mu Cp divided by K raised to n dash. So when this is again, we can HD divided by K is equals to C into bracket rho dV divided by mu raised to m, and this is mu Cp divided by K raised to n, and nu Nusselt number C into Re raised to m PR raised to n. This is Nusselt number, and where C and m and n are constant and evaluated by experimentally, that is Nusselt number HD by K, Prandtl number mu Cp by K. So this is the solution for the force convection. This is one of the example for the force convection, right. So next we'll take another example for free convection. Free convection, right, applied to the free convection or natural convection. Dimensional analysis for free convection, right. Here dimensional analysis for the heat transfer coefficient in case of natural or free convection like force convection, heat transfer coefficient depends upon the variables V, rho, K, U, mu, Cp and L or D. Since the fluid circulated free convection is owing to difference in density between the various fluid layers due to temperature gradient and not by external agency. Therefore, velocity V is no longer an independent variable, depends upon the following factors, that is the difference of temperature between heated surface, coefficient of volume expansion, acceleration due to gravity, etc. Thus the heat transfer coefficient H may be expressed as that is delta temperature difference, etc. The parameters B, G and T represent the buoyant force and dimensions L and 3. Total number of, so H is equals to, we can write F rho L mu Cp K B G delta T, right. We'll discuss later on in the next lecture. Thank you. We'll start again. Thank you.